Hi, once again, viewers and listeners. This is Mark Griffin, Director of Customer Solutions here at Construx. We are a team of software engineering experts led by legendary author Steve McConnell. Here we believe every software team can be more successful at delivering higher levels of business value. In any normal episode, we would be talking with one of our consultants, exploring one of our different types of engagements. We would describe the issues those engagements were designed to address and how we solve them. Today we're coming to you once again live, letting you see our smiling faces in our home office and my internet incompetence. This is our 20th podcast, a bit of a milestone as we continue to share our work with all of you. We are continuing on our 7th episode in our series covering the key principles in Construx CEO and Chief Software Engineer Steve McConnell's newest book, More Effective Agile. You all know Steve and his history of work in our industry, so I'm not going to recant that detail because I think we've been friends for 19 weeks now, and you've listened to the first 6 of these. So welcome back, Steve, to the podcast.
Mark, it's great to be back, and congratulations on your 20th podcast.
It's pretty cool. In today's episode, we're going to cover an additional 3 principles under the heading of minimize the defect detection gap. We actually started talking about this broader topic as one of the principles from episode 6.
Right.
Recalling from that conversation, we talked in higher level terms, this being about how long a defect exists in the course of project development timelines, and then by letting detection lag, the cost of that latency. So we're going to talk today about 3 principles that help to minimize the detection gap.
Okay.
And let's touch on the first key principle, and that's a practice in Agile that's well known. And we touched briefly on it in episode 6, and that is create and use a definition of done. We talked about its sister principle, the definition of ready, which allows backlog items to enter a sprint. So tell us about this particular principle, Steve. What role this plays in minimizing when a defect gets inserted and when it's detected? It's really about bringing QA work closer to the other work normally done in a sprint, correct?
Well, I'd say it's partly about bringing QA work closer to the other work, but it's also partly about just integrating QA expectations as part of the work in general. Some of it's about eliminating the divide between the thought of QA work being separate from the regular work. So the definition of done is really, I think we talked about this last time. In a lot of ways, it's kind of like the old idea of an exit criteria. But it really is about essentially exit criteria on individual work items. So it's giving some clarity around when do we declare something to be done. And prior to the adoption of the thing that we now call definition of done, we worked with a lot of teams where teams would adopt this vernacular of, is it done? And somebody would say yes. And then they would say, is it done? And then they would say no. And teams would actually be quite official about saying done versus done, having 2 kind of well understood meanings in those teams. So definition of done is a way to, in a way, kind of formalize that concept and make it clear about when work is actually done. And it really can be applied to anything. It can be applied to, nominally it's applied to functionality, but it can be applied to other work items as well. But nominally it's about completed functionality.
So you might also apply it to things like design, for example.
You could potentially have, if you're doing some, this is less common in Agile development, but if you do have a need to, say, do some architecture where you're not immediately driving that architecture into code, where you could apply an end-to-end definition of done to it, then you could conceivably have some notion of a definition of done. I would not say that that's common, but you could, it would be something that you could consider.
Sure. And then, you could even extend that across the life cycle. So you might have something for coding complete, you might have something for testing. Not as normal, not as typical.
Yeah, I think what would be more common is to say that the definition of done would include any necessary work on architecture, any necessary code review passes or static code analysis, unit test coverage, and so on. So it would be more a matter of the definition of done, including what often would be described as or thought of as collateral work. And to me, I think the definition of done, one time it becomes really critical is if the team is feeling schedule pressure, feeling rushed to complete something. That's the time in a project where teams start to take shortcuts. The definition of done gives the team a tool they can use to avoid taking shortcuts and really to just remember to follow through on their best intentions and say, all right, yeah, we've got a lot of stuff to do and we're in a hurry, but we still have to make sure everything's actually done when we say it's done. Otherwise, we call it a shortcut, but it doesn't really shorten anything. It actually makes things take longer in the long run. And so when we've just had all kinds of experience for decades of people being pressured to take shortcuts or feeling pressure to take shortcuts, and then things actually get worse instead of better. So I think definition of done is a good safeguard against that.
That makes a lot of sense. So, you know, teams build a checklist, and effectively they have something that they agree to that they use to. What are some common examples of those kinds of things?
Yeah, so common examples are obviously builds without errors, passes its static code analysis. If there's code review, passes that, passes unit tests. The unit tests are written, unit tests work. I mean, these are the kinds of things that get included. Really, what you're trying to do with your definition of done is to say that all of the work that with incredibly minor exceptions, all the work that's needed to declare the thing done so that you really never have to touch it again is in fact done. And I think that's the standard is does your definition of done account for essentially just being able to say that I'm never going to look at this code again unless there's a change that affects this code. So and I think problems with definitions of done. If a one problem with definition of done is that it can be overly porous and can let too much untracked work or undetected work slip through. And so we'd like to have a fairly tight definition of done that does not let very much stuff slip through.
So that's a good segue. I mean, you mentioned that. I mean, what are some other common problems you might have with definitions of done that maybe the team didn't set something up in a good way? Maybe things like you've got stuff that's just not releasable yet, right? You've got stuff that's shaky.
Sure, yeah, trying to apply a definition of done before stuff's done is all that really does is just repeat your task list of work that you already knew you had to do. Now, I think in general, definitions of done, the problems are either that they're not strict enough, and so the things aren't really done, or they're too strict to a degree that's unrealistic. And strict is probably not quite the right word, but really what would be problematic is just if we get this really long checklist that looks bureaucratic and doesn't actually serve the interests of the team, then people can start to blow it off, and uh, it probably needs to be pared down somewhat. So anyway, so I suppose you could characterize that as not strict enough, which is probably the bigger problem, too strict, which is another problem. When you get into legacy code in particular, too strict does become literally a problem just because, sometimes it's just too much work to move the mountain of legacy code to meet some current definition of done. I think of it as being a lot like building codes where, the building code, if you're making a new building, you have to conform to current building codes. Typically, with building codes, if you're remodeling an existing structure, you have to bring the part that you're remodeling up to the current building code, but you don't have to bring the entire structure up to the current building code. And I think that's a pretty good way to think about working with legacy code as well, where the fact that you touch a tiny piece of code inside a huge legacy system doesn't mean you now apply the entire definition of done that you'd use for new development to everything, but you might consider applying it to the part that you're touching. Uh, and I guess the last thing I'd mention about common problems with definition of done is if somebody just copies a definition of done out of a book or off of the internet somewhere, and it has maybe is a little bit overly theoretical or overly ivory tower, then it's not necessarily very well adapted to the needs of the specific team. So I think I think it is important for the team to define its own definition of done. It probably is going to end up looking a lot like lots of other definitions of done, but it's important for the team to buy into their own definition of done to see why the details matter and why the details apply to them specifically.
That makes total sense. So you really want this stuff to be evidence-based. There's got to be something in the process that you have recorded that the team agrees to. You don't want it to just to be activity-based,
Yeah,
right?
absolutely. I mean, one of the focuses of Agile is that it's supposed to be an empirical orientation. And so if we're not paying attention to what is actually happening on the ground in our projects, then I think we're missing out on some of what's good in Agile.
Yeah, and I think that we've covered that in some of the prior episodes, for sure. What about, are there situations where you might have more than one definition of done? Is there any reason why for different types of work,
Yeah,
you might write something different?
there can be situations like that. I think, in general, we try to get one definition of done wherever possible, but this goes back to the point you just made about paying attention to your ground state or your ground truth, and the empirical reality of where you're working. If you're working in an environment where you've got a highly regulated environment where documentation is a big aspect of what you're doing, we've seen companies that have a separate definition of done for documentation than they have for functionality and code. To me, that is very sensible. I think what we're trying to avoid with multiple definitions of done is weakening uh, a definition of done, our primary definition of done. So when we're applying it to two really separate things like code and documentation, I think that can make sense. We do a lot of work with companies that do software development in a hardware context. And so sometimes the hardware is not available at the time the code is initially being written. And so having a definition of done for code that's working with emulators versus code that's working with the actual hardware, that can make sense. And then we talked a little bit about legacy code. I think it can make sense to have and work on a legacy system to start with a looser definition of done than you would normally start with for greenfield development, and then to ideally to tighten that up over time. But as I said earlier, you can't really start with a well, it's not always true, but sometimes it's difficult to start with a really rigorous definition of done in a legacy environment.
Right. And then one of the other things I was going to bring up is this notion of potentially external contractors who maybe develop code for you that you're not necessarily in control of some of that. So you need to be building something into your definition of done that can somehow account for that external dependency. Does that make sense?
Yeah, I think that makes sense. It's interesting. I think in general, for internal purposes, definition of done amounts to exit criteria in traditional terms. If you're going to apply definition of done to work that's being submitted to you by a contractor, then essentially that amounts to acceptance criteria for accepting the work from the contractor. Um, and I think that makes sense. Again, I would say that is not one of the more common usages of the term that we've seen. But if a team wants to think of that in terms of definition of done and applying that, I think that's certainly a logical way to approach it.
Well, that's why I'm here, Steve, just to stump the band. So I'll ask the same question in the last episode about the definition of ready. Does the definition of done necessarily stay fixed in time? Meaning, can the team inspect and adapt on a different set of criteria, maybe based on some retrospectives they've done, or if maybe they're a new team spinning up and they need to make sure that they account for something that maybe caused them some issues in a retrospective and they want to change that? Is that typical?
I think I think everything is potentially fair game for inspect and adapt, and I do think that teams will probably, at the very least, sharpen up their own internal understanding of their definition of done as they continue to work with it. Um, but I think that what we don't want to do is we don't want to just say, "Oh, hey, this seems like a good idea," and then okay, yeah, let's do that, and then they just do it, and then you accumulate all these things that seem like good ideas, but you're actually moving backwards instead of forwards. It really is important that we do inspect and adapt, meaning we're actually paying attention to the reality on the ground, and then we're adapting, making changes, but we're also keeping a feedback loop there where we're making sure that the changes are actually moving us in a positive direction. It's not really change for the sake of change, it's change for the sake of improvement. Um, and the fact that the team doesn't like it, I think um, teams and organizations do have difficulty as they adopt definition of done, and that's partly by design. I mean, partly you want to create difficulties for formerly overly sloppy practices. And so a lot of times when a team first starts using a definition of done, it'll feel like they're slowing down. And indeed, in a sense, they are. It's forcing them to slow down, to be more deliberate about their work, to actually finish one thing before they move on to the next thing. But what you don't want is the team to say, oh, wow, this is making us slow down. And so then they relax one piece of the definition of done, and then they relax another piece. And before you know it, there's no definition of done anymore except in name only.
Boil the
And,
frog.
this is a pathology that we see over and over and over again, where teams adopt the names of things, but they don't adopt the substance of things. And then they wonder why things aren't getting any better. And, there is a little bit of a, taking your teaspoon of cod liver oil here where it's not going to be fun at first because it's going to force you to realize that you're not moving as quickly as you thought you were. And I go back to the old expression that uh slow is smooth and smooth is fast, and so we got to slow down, smooth things out, and then we can speed up.
No, well, those are great closing thoughts. I think we've beaten this principle up pretty good today. So let's move on to the second principle, and that is maintain a releasable level of quality. So we're talking about defect detection gap. This principle seems like a no-brainer, right? I mean, we're not talking about individual backlog items though, right? This is
Not
different than that.
typically, not when we're talking about releasable level of quality.
Right. I mean, you're talking about bringing something to that level of quality, say over, what kind of time frame are we talking about?
Talking about Scrum, we're typically talking about making sure that it's at a releasable level of quality by the end of the sprint. And if we have super good discipline, then we're going to try to stay really close to that releasable level of quality at all times effectively. But I think what this is, the way that it's different from the definition of done, is it's essentially an acknowledgement that says there are times when we kind of need to let things loosen up for a short while, where maybe we can't force rigorous definition of done minute by minute. So we need to let things loosen up, but we also need to make sure that that isn't allowed to persist for very long. And so on some cadence, on the Scrum cadence of 1 to 3 weeks, we're going to bring it back to a releasable level of quality. And if we need to let it get a little bit sloppy for a day or two, okay, fine. There are times when that has to happen, but we're not going to let it get sloppy for a month or two. We're going to bring it back back into alignment more often than that.
So one of the emphases of your book was really addressing Agile in the leadership context, and one of the things that leaders are constantly interested in is sort of planning and tracking. So one of the side benefits, I think, of having something like this, like having this definition of a potentially releasable thing, is actually that's helpful for planning and tracking, right?
Oh yeah, I think what we don't want to have happen is we don't want a lot of work to accumulate off schedule. And this is really one of the failure modes of waterfall development, was that we just weren't aware of how much work wasn't getting done along the way because it wasn't as iterative and incremental. And by making it more iterative and incremental, we can have a greater awareness of what work we really need to be doing along the way, but we can go beyond that with bringing things to a releasable level of quality by just having that extra step that says, okay, all that work that we kind of wanted to put off, we're not going to put off. We're going to actually finish that before we declare the sprint to be done. So, yeah, I think, work accumulates off schedule in a variety of ways. It can be like cleanup work, it can be documentation work, it can be, just not fully, creating all the unit tests that need to be created. It can be not doing changes, to related parts of the system that aren't brought up to the same level of quality as the part you're directly working on right now. All those scenarios are recipes for either degrading code quality over time or degrading velocity over time. So what we really want to do is just, the general idea here is we want things to, when we say things are done, we want them to actually be done.
Done.
And
Absolutely.
so, I kind of think of maintain a releasable level of quality as a wrapper around the definition of done, where definition of done applies in the small, maintain a releasable level of quality applies at a slightly higher level of aggregation, but not an
Right.
enormously larger level of aggregation. It's not
No.
project level or release level, it's sprint level.
Right. And now I think we've worked with some clients who've struggled with adoptions where they would do a normal sprint, maybe it's 2 weeks, and then every 2 or 3 sprints they'd have something they used to refer to as a hardening sprint. And that kind of that kind of implies that you're really not driving to a releasable level of quality within the sprints. You're saving it for an extra little cycle that needs cleanup work, right?
I think that's mostly true. Yeah, I think for most contexts, if you're doing hardening sprints, it probably means you're not actually doing enough quality work along the way, and you're not really adhering to a definition of done, and you're not really bringing your software to a releasable level of quality as often as you should, and you're probably experiencing some problems as a result of that. I think the proper place where it makes sense to have hardening sprint is in the cases where there's some external dependency that you just don't have the ability inside the team, no matter how well you organize your work, no matter how hard you try, there's an external dependency that prevents you from being fully done. The example earlier of in a combined hardware software environment where the hardware is not ready and you're initially writing software for an emulator. Well, you can't really completely harden the software, so to speak, if you're not actually working on production hardware. So, there it makes sense to have a hardening sprint. And if there's a surprise, it really should be a surprise that comes because there was something that was a mistake on the hardware side, or, there was some documentation error on the hardware side, or something like that. But it really shouldn't be that the software part wasn't done to the best of the team's ability to get it done in the emulation environment. So, um, we've seen teams working in regulated industry contexts where the hardening sprint ends up being for documentation. In general, I'm not super enthusiastic about that. I think it's better to work the documentation into the sprints. Uh,
Hmm.
but we've seen just about everything in one company or another we've worked with, so it's hard to make any absolute statements about it never making sense. And every
Right.
once in a while we see something that really isn't like other things we've seen, and so that has come up in the work with regulated or companies working in regulated environments where it actually makes sense to do a documentation hardening sprint from time to time.
Right, and verification, validation cycles, for example, or even in situations where an auditor asks for evidence, and it's not necessarily part of your product delivery, but it's something that has to be given to an auditor to verify that you've stated what you're going to build and you can demonstrate what you've built.
Yeah,
Right.
and I think so that's an example of, in a sense, an external dependency where you've got the external auditor. My favorite example in this space, which I think I brought up in a prior podcast, was uh, a team that was relying on or doing software that was in support of a biological testing process, and the actual biology of the test took 30 days, and so they can't shorten that. They have to wait for the test to work through its biological process, and so every once in a while you run into something like that where you can you can say 2 week sprint all you want, but when you've got a natural process that takes 30 days, then you're going to have to figure out how to deal with that.
Yeah, exactly. That's a great example. I mean, a reminder that when we're talking about this is we're talking about potentially releasable, and I know that our service providers, when they're on the ground talking to people about this, is that the key word here is potential. Potentially, you don't have to necessarily release. It's the potential is there, and
You know,
somebody can make the decision to do that.
I got interesting feedback on that phrase during the manuscript review part of the book, and I got some really interesting pushback on the word potentially, and I ended up agreeing with it, and so I mostly removed that phrasing from the book, where a couple people said potentially releasable and releasable mean the same thing. Releasable does not mean released; it just means it's releasable. And the comment they made was that when they inserted the word potentially, they found their staff actually interpreted that as wiggle room, and that the quality didn't seem like it had to be quite as high if it was potentially releasable as if it was releasable. And so they prefer using the phrase, just using the word releasable. And I ended up thinking that made a lot of sense. So I adopted that terminology and mostly just refer to it as releasable.
Okay, I stand corrected.
All right. Well, that's great. After 8 podcasts, you've learned one thing, so that's good.
You finally got me.
Yes.
Yeah. So that brings us to our final principle for today, and that's related to minimizing the defect detection gap. That is, use automated tests created by the development team. I mean, we're now in the domain of testing with this particular principle, which is where I think we've always normally thought about defect detection removal in some kind of a testing capacity, whether it's developers doing it or downstream testing people doing it. So agile practices have really made the test responsibilities shift left. More emphasis on testing by developers, you say specifically in this principle, by the development team. So passing these tests should be part of the definition of done that we just talked about. So what are some of the kinds of testing that you're referring to when you're talking about these things?
Well, I want to answer that question, but first I just want to say I think this is an incredibly meaty key principle. I mean, use automated tests. That in itself, it's not just tests, it's automated tests created by the development team. And this is not saying created by testers, it's saying created by the development team, which includes developers. And so we've got a lot of meat here saying tests are going to be created by developers,
Big
automated
words.
tests are going to be created by developers, and so on. And so there's actually a huge amount of shift from the historical focus on tests being created by testers and minimal responsibility for testing on the part of developers. And then automation is almost another, it's not almost, it really is another topic in its own right. So this is actually really, there's an awful lot of meat behind this particular key principle. So when we're talking about types of testing, I'm really referring to essentially, all the tests that we can do: API testing, unit testing, integration test, acceptance test, user interface, basically everything.
Yeah, and that's I think you're right about this. I mean, there are a lot of heavy words in that string, and I think one of the things I think about is that these tests really should be incorporated into automated build and deploy systems, right? If you're talking about going faster, if you're talking about eventually getting to some CI/CD, DevOps kind of an environment, you need this automation. This has to be there, right?
Yeah, I think that's a really interesting point. I think that um, if you're automating for the sake of automation and all you're going to do is use that to do what you were doing before, but now it's automated, I think it can be kind of hard to justify the effort just to do what you were doing before. But the interesting thing about this, and I think this is the interesting thing about advances in technology and practices in general, is that when you automate, there are additional opportunities that open up that weren't there before because there was just no way that you could do these things if you were going to do it manually. So, the notion of continuous integration, continuous uh, delivery, or continuous development, DevOps, these are just not going to happen if you're doing manual testing, or at least they're not going to happen very well. You're probably not even going to consider doing them. But once you kind of take the step into a high degree of test automation, now other things become possible and practical and not overwhelming that were before. So, the idea that you're going to run tests every time the code is checked in. Well, I'm not going to do that if I'm going to do the testing manually, but if it's just a matter of
No.
launching it as a background process, then why not? Uh, and likewise, the idea that I'm going to push code to production, every day, or we have lots of famous examples of companies doing it more often than that. I can't go through a manual testing cycle that often. It's just not practical. It's not economical. But if computers are really good at doing things quickly and repetitively. And if I can write the automation so that the computer now takes on the repetitive task of doing a whole bunch of testing and making sure it's okay to push the code into production, then great. Now I've opened up a possibility that just wasn't there before with a more manual process.
Right. And you free up bandwidth as well, right? I mean, if you can automate some things, and there's more in-depth testing, the nature of your testing can get more more sophisticated because now you have bandwidth that can be focusing on those kinds of things to trap further defects, right? Things
Yeah,
like
and one
that.
point I make in the book is that I think in general, developers like this kind of automation work. Developers don't, well, developers, being a subclass of the class of human beings, tend not to like super repetitive tasks. And if you're having to go through manual testing, it becomes repetitive and boring. But for most developers, if you can spend 2 hours manually testing something and making sure that it works properly, or you could spend an hour and 55 minutes writing automation for it and then do the automated test in the last 5 minutes, nearly everybody would choose to spend the hour and 55 minutes to do the automation and then have the manual part be only 5 minutes long. And I think this goes back to that whole autonomy, mastery, and purpose discussion where if I'm doing kind of rote activities that really the computer could be doing instead, I'm not feeling a lot of mastery in that scenario. But if I'm writing
Exactly.
automation and every time I actually launch my automated tests, I feel a little bit of satisfaction over the fact that, hey, I automated that and now it's easy, that actually contributes to that feeling of mastery. And so, interestingly enough, I think the automation piece of this key principle does provide useful support for the team feeling that sense of autonomy, mastery, and purpose.
Yeah, anything that eliminates future work or can minimize future work, I think engineers tend to like to do something about, right? I think that's the nature of an engineer, right? I don't want to do this. I don't want to do this grunt work again. I
Right,
want to
and it
do this.
predates
I want a
computers
machine
too.
to do this.
The whole idea, of just the engineer doing all kinds of crazy things in their home environment to make things easy, or putting in levers that do things automatically. This is deep in the race. It's not just software.
Oh, totally, totally. And I think I think about today a lot of the clients that we work with. Many people moving things to the cloud, right? So by definition, when you are an Amazon or a Netflix, you're a master of that environment. There are a lot of people that are moving that direction. Don't necessarily need to release as frequently as Amazon or Netflix do, but having the automation and the ability to do so and pull the trigger, maybe it's every other day, every day, or a couple times a week, something like that. Sometimes that's even an enormous hill for many companies to deal with. So getting a handle on automation for cloud deployment strategies is probably a really good thing.
I think so, and I've been a little bit surprised to the degree that companies that are nowhere near the cloud and are never going to push code to production multiple times a day because the code is, it's in an automobile that's under development or it's in a tank or something like that. Um, they still say that they've found value in having the discipline of pushing the code into, maybe it's just into the test environment for the system test people to look at, but they still find value in setting up what otherwise might be called a CI/CD pipeline, even though there's no actual CD going on in any normal sense of the word. But the discipline that they get out of that and the focus on automation, the elimination or reduction of repetitive tasks and so on, they still find valuable. And I guess to me, that's been a learning over the last few years is, if you'd asked me this question 5 years ago, I would have said, okay, yeah, primarily of interest to cloud companies like Amazon and Netflix and mobile devices and so on. But I think today we've seen enough cases where even in what you might consider to be like legacy environments, big legacy environments, uh, manufacturing or whatnot, teams are finding benefit in doing this. So, I'm not going to say every team should always do this 100% of the way, but I'm going to say that if a team's not doing it at all and they think that there's no real benefit in their environment, I think we've seen enough cases where there is a benefit that they should take a hard look at it and see if there might be some, maybe they won't get the primary benefit, but there could be some secondary benefits that are actually pretty valuable.
Well, that makes total sense. You mentioned the hardware or software environment in earlier in the podcast, and I think that's another place. I think about that in my hardware background, where we were deploying software on multiple different platforms, right?
Right.
And you certainly don't want to do those one-off manual. That would drive somebody to distraction. I think you definitely want to automate that.
It's not that
Parallelism
we
and
haven't seen that. We've seen examples of companies maintaining more than 100 code branches through manual revision control practices,
yeah,
for
it's awful.
example. But yeah, I certainly didn't recommend that.
Yeah. I mean, the virtual environments, I think like that, there's lots of things that people do to make that work.
Yeah.
What about, I mean, we touched a little bit on legacy code. Is that even possible to automate stuff associated with legacy code, or how would you even think about doing that?
Yeah, I mean, I think, here we just have to be, I think in general, as we approach work in legacy environments, we're going to end up being more selective about what we do and what we don't do. The general guidelines of the stuff that we touch more frequently, we might have cause to automate that. But there's no real virtue in automating something that we don't do very often. And so, I think automating the stuff that we're touching frequently makes sense. Stuff that's stable and has been stable for a long time. We certainly see lots of companies that have code bases that are 10 to 20 years old, or parts of their code bases are 10 to 20 years old. A lot of that stuff falls into the category of don't shake the jello, where if it's been working for
Yeah.
5 years and there's no need to change it, then let's just leave it alone.
Yeah, I think that's a great thought, and then maybe a great closing sentiment. I think that's really good. I think we're going to have to probably leave it here for today. I think our listeners gained a lot of insight into how we think about this particular environment, and I think that's again, I think I really appreciate you taking the time to sit down with me today and talk about this particular thing and these supporting principles.
I always appreciate the conversation, and I always like the way you set up the questions.
Yeah, well, I appreciate your patience today. We had a little hiccup with my connectivity, but that's life. So we move on. We turn the page. So thank you, listeners, as well. If you've been listening to us live this time around, be sure to tune in again for another episode of Inspect and Adapt, the Construx podcast. Until then, this has been Mark Griffin as your host. Liz Ostaszewski has been our audio engineer, and Devin Musgrave is our producer. If you enjoyed this episode, feel free to give us a positive rating on Apple Podcasts, Spotify, Stitcher, Google Podcasts, or wherever you normally find us. If you have comments or would like to talk to one of our practitioners about this subject or any other subject we've addressed, and you have ideas for a future podcast potentially, reach out via email using comments@construx.com. Again, that's comments@construx.com. We'd love to hear from you. So keep staying safe out there, everybody, and have a great next sprint.